Lesson 4.5 is solving equations. It's all been about all this rational stuff, right? And now we've got to solve the rational equations. And as we talk about solving rational equations, remind me what it means to be rational again? It's what?
A real number. A positive.
Okay, so if something's rational, it's something that can be expressed as a fraction, right? So when we talk about a rational equation, that means it's something that has a fraction in it. And any equation you look at on this notes page has fractions in it. So rational equation contains at least one rational expression. So in other words, it contains at least one fraction and an equal sign. Okay. Easiest method to deal with these rational equations is to get rid of the fractions. And so that's what we're going to focus on today, is we're going to talk about how to clear the fractions out. So we're going to use the idea of finding the least common denominator, and we're going to multiply by it to clear that out. Now, that is more on the back side, but we'll talk about it a little bit here on the front side. And then a big thing in this lesson, anytime you work with rational equations, is we have to think about extraneous solutions. And extraneous solutions are basically solutions that you get legitimate answers, but then they don't work when you check them. And so that's where today, I hate to be the bearer of bad news, but it is important that we check our answers. Now, the good news, I'll be able to give you an easy, quick way to check. You won't have to plug them all the way back in and go through a bunch. I'll be able to give you an easy, quick way to check. Okay? So, now we're going to start basic. Just one fraction here, right? And I'm going to teach this one a little bit differently. So my first equation is 2 over x plus 5 equals 4. Or I can also think of reading that as 2 divided by x plus 5 equals 4. If it's 2 divided by x plus 5, how can I get rid of that fraction? Yeah. What's the opposite of dividing by x plus 5? And that is to multiply by x plus 5. And so the easy thing here, when you just have one fraction, we're going to multiply by that denominator. If I multiply the left by x plus 5, guess what? We're going to multiply the right by x plus 5. Now on the right, I'm going to think of it as being in parentheses. On the left, I'm going to think about it as a fraction. So think about what happens here. If I have x plus 5 over 1 times 2 over x plus 5, what do you know? X plus 5 on top? We'll cancel with the x plus 5 on bottom, yes? If those cancel, and they just become 1s, what remains on the left side? 2. So we're going to have 2 equals 4 times x plus 5. And so by multiplying by that x plus 5, we just turned it into a very easy equation. This is something I would call a very easy equation. What do we have to do here? Okay. Since it's 4 times x plus 5, if you haven't already, distribute the 4. So 2 equals 4x plus 20. Continue solving with me. If it's 4x plus 20, what do we do? Okay, work to get your x by itself. So if it's 4x plus 20, we're going to subtract 20. 2 minus 20 is negative 18 equals 4x. If it's 4x equals negative 18, how do we solve for x? Divide by 4. If I divide by 4, I'm going to have x equals, and my brain is just thinking negative 18 fourths. What do we know about negative 18 fourths? Okay, it can reduce. We could reduce it to Negative 9/2. And that would be a perfectly fine answer right there. Okay, I didn't even have to get my calculator out. Savas would probably not take negative 18/4. I don't really want negative 18/4. I do want to reduce. So negative 9/2. Now, depending on the situation, if Savas would allow you a decimal, you could also express negative 9/2 as negative 4.5. And I would be perfectly fine with a decimal there too, because it's not something I had to round. If I had to round it and change the value, I'd be a little bit different, but because it's an exact decimal like that, we can do that. Okay. Doable? Only had one fraction, right? Okay, let's practice that again real quick, and then we'll look at our word problems. B, 1 over x minus 7 equals 2. How are we going to get rid of that fraction? Okay, since it's dividing by x minus 7, we're going to multiply by x minus 7. We're just using the opposite operation there. What I do on the left, I do on the right. On the left, when I multiply by x minus 7 on top, x minus 7 on bottom will cancel, leave me with what? 1. Equals, on the right, it's 2 times x minus 7. So you need to distribute. And that becomes 2x minus 14. It's 2x minus 14. I want to add the 14. 1 plus 14 is 15. And if it's 2x equals 15, I'm going to divide by 2. X is what? 15 over 2. What do you know about 15 over 2? Okay. 15 over 2 is a perfectly good answer. That's honestly what Savas is going to likely want, would be my guess, because they tend to want fractions more than decimals, don't they? So it is as a decimal 7.5. I would be fine with that. There's a chance Savas might want the decimal. You never know. Weird things happen, right? Okay, so that's a basic. When we get to the back, we'll talk about some fancier, more complicated problems that have more denominators. But it's going to be the same idea that we're going to be multiplying by whatever the denominator is, or least common denominator, to clear out those denominators. Now, before we go there, though, we need to talk about a word problem or two. Okay? These are traditional algebra type word problems, and I thought it was probably good to make sure you have an idea of how to do these. So let's look at the first one. Arthur and Cheyenne can paint a wall in 6 hours when working together. Cheyenne works twice as fast as Arthur. How long will it take Cheyenne to paint the wall if she were working alone? Okay. So these are called solving work rate problems. And what we've got to do is we've got to figure out each person's work rate, okay, and the together one. So let's go for the together option first. What do we know about Arthur and Cheyenne together? Together they can paint what? One wall in 6 hours, yes? Now, if they're painting one wall in 6 hours, what can they paint in 1 hour? Huh? A sixth of the wall, yes? And that the idea is that is their rate, is that they can paint 1/6 of a wall in 1 hour. Because what we're trying to do is we're trying to find everybody's rate for 1 hour. Because right now, they're kind of all over the place. And we need to know what everyone can do in one set amount of time. So I'm trying to look in 1 hour. So that is 1 wall in 6 hours, which translates into together they can paint 1/6 of a wall in 1 hour. Now let's look at, let's see, Arthur was the original one, yes? Okay, yeah, Cheyenne is based on Arthur. So let's talk about Arthur. What do we know about Arthur? We don't have specific information, do we, other than he's slower. Okay, Cheyenne paints faster. So we're going to say that he can paint 1 wall, and we don't know how long he takes, so I'm going to say in X hours. In other words, we're using X to represent how long it takes Arthur to paint a wall. Okay, so he can paint 1 wall in X hours. With that information, what can he paint in 1 hour? Yep, exactly. In 1 hour, he can paint 1 over X. Okay, so he can paint 1/x of a wall. I don't know, is that a proper way to say it or not, but he can paint 1 over X of a wall in 1 hour. And it's not that you have to write all this information out right here, but this is the first time we've done these. I want you guys to have the information to look back on. And what do we know about Cheyenne? Right, she is twice as fast. We don't have anything more specific there. But if she is twice as fast, we'll be smart about this. If Arthur's rate is 1 over X, she's twice as fast, so her rate is 2 over X. In other words, she can paint 2 over X of a wall in 1 hour. Okay, guys. We're ready to write our equation. We have all the pieces. It's a very easy equation to write in that whatever Arthur can do plus whatever Cheyenne can do is going to total whatever they can do in an hour. So do you see this? So my equation then can be written as Arthur's 1 over X plus Cheyenne's 2 over X, and that's going to equal their together 1 over 6. That's the equation that represents this situation. Next time you are welcome to skip writing all these details out, but I thought it would be helpful to have in your notes. Okay. This time I have 3 fractions, but they're easy fractions. I still want to get rid of my denominators. What do I have in the way of a common denominator? There's a 6 in my denominator, and there's what else? X. So what's my common denominator? 6x, right? Because between 6 and x, that represents every one of my denominators. So my least common denominator here is 6x. And that's what I'm going to multiply both sides by, is 6x. And what's 6x as a fraction going to be? 6x over 1. Okay? So, we're going to have to do 6x times 1 over x, 6x times 2 over x, and 6x times 1 over 6. Maybe you can see this okay, maybe not, but I'll write out the individual pieces this time. If we think of it as 6x over 1 times 1 over x, what cancels? X's cancel, remaining leaves me with what remaining? 6. So that's going to be my first piece. Plus. Now I'm going to do 6x over 1 times 2 over x. That's doing the second piece. What cancels? X cancels with x. Leaves me with what remaining? 6 times 2, which is 12. And on the right, 1 over 6 times 6x over 1. What cancels? 6's cancel, leave me with x. Man, this equation became so easy. What do we know? X equals 18. Now, last step of a word problem is always, what did the question ask me and have I answered that? Well, what did the question ask me? We want to know how long it's going to take Cheyenne to paint the wall. Well, realize this 18 here is how long it takes Arthur to paint the wall. Because he can do one wall in X hours. We found X to be 18, right? So we have discovered that Arthur can paint the wall in 18 hours. Well, okay. The question asked for Cheyenne, so we need to go a step farther and talk about Cheyenne. What?
9 hours.
9 hours because, think about it, she can paint twice as fast. That doesn't mean we want to do 2 times 18 though, does it? We want to split her time in half, or split Arthur's time in half. And so Cheyenne can paint one wall in 9 hours. Okay? So always stop and look and see what the question asked. Sounds silly, but man, it's so easy to miss a problem by not answering the right question. Okay. B is similar. Let's take a try at it. Instead of painting a wall, we're filling a pool. It takes 12 hours to fill a pool with 2 pipes, where the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? Okay. I'm still going to write out a little bit of information. You may go straight to your equation. What do we know about the 2 pipes together? It's 12 hours. And so if it's 12 hours, right, that's one, they can fill one pool in 12 hours. So what is that rate? 1 pool in 12 hours, so 1/12 rate. And then we have one pipe flows 3 times as fast as the other pipe. In my notes, I used one pipe and I used other pipe. How about we use the slower pipe and the faster pipe? And I wrote slower piper. Not slower piper. Slower pipe. Okay. What do you know about the slower pipe? Other than it's slow, we don't really have any information, so what are we going to set up? It can fill one pool in X hours, and so its rate is 1/X. What about the faster pipe? We just know it's 3 times as fast So what are we going to use? Three over x. You're solving your equation. Did you write your equation? Let me back up and ask that. Okay. Together, they have a rate of 1/12. We're basically going to take the slower rate, the slower pipe, 1 over x, plus the faster pipe, 3 over x, and together it's going to equal 1/12. Okay. How can we get rid of denominators? Multiply by what? 12x? Because they all have a 12 or an x as a denominator, right? So we're going to multiply both sides of my equation by 12x, which is 12x over 1. Okay, you got it? It's 12x over 1 times 1 over x for my first distributive. What cancels? X, and we're left with 12. Then we're going to take the 12x and we're going to distribute it to 3 over x. So 12x over 1 times 3 over x, what cancels? X cancels. What remains? 12 times 3, which is 36. And then 1 over 12 times 12 over x. What cancels? I said that wrong. 1 over 12 times 12x. 12's cancel, leaving me with x. And if only they were always this equal or easy to solve. What do we get for x? X is 48. What is that 48? Okay, that's your slow pipe, yes? 1 pool in x hours. So the slower pipe is going to take 48 hours. Because I want to ask, how long is the faster pipe going to take? I did it again. I wrote Piper, didn't I? Faster pipe's going to take how long? 16 hours? Because it's 3 times as fast, so divide by 3. What did my question actually ask? Slower pipe. Did I answer that? I did. Okay, guys, you're going to see a couple word problems similar to that in homework. Hopefully you're prepared for that now. Again, these are traditional algebra word problems. I feel like they are types of problems that you could easily see on like standardized testing and whatnot. Okay? I don't know if you still do, but I know in the past I've seen them there. So, good ones to look at. Okay, ready for the backside? Where are we at? We'll at least get 1 in, maybe 2 in. Other than that, we will pick up tomorrow. So on the backside, you don't get just one fraction. We have multiple fractions here. And our job is to solve and, of course, check for extraneous solutions. Even though this is quite different than last lesson, one thing is similar. What do you think I'm going to suggest you do with your denominators to begin with? Let's get them all factored, right? We want to know what these denominators all are in factored form, because that's going to help us find our least common denominator to multiply by. So we already have x minus 5. We already have x minus 3. What about x squared minus 8x plus 15? Does it factor? X and x. Multiplying to be 15. It's 5 and 3. Adding to be 8 is 5 and 3. To make those signs work, they both need to be negatives. Surprise, surprise. Same factors from your other denominators? Okay. My question becomes, least common denominator. What do we have pieces in common? Two of my denominators have n x minus 5. Two of my denominators have n x minus 3. Anything else? That covers that covers everything, doesn't it? So that means my least common denominator is x minus 5, x minus 3. And that means that we're going to take this entire equation, both sides, left and right, and we're going to multiply by x minus 5, x minus 3. The left side and the right side. Okay? Multiply the whole thing by x minus 5, x minus 3. Okay. Since we're beginners at this, I'm going to write it out the long way the first time through. Okay? You can choose to not write it out the long way if you want, and that's perfectly fine. But the long way, because that way I can show the canceling. So the idea here is I'm going to kind of space out my equation. I'm going to have 1 over x minus 5 plus, I'm going to leave a gap so I can show what I'm multiplying by. And then there's my x over x minus 3 equals, and I don't necessarily have to leave a gap here because I can put it afterwards, but this is 2 over x minus 5, x minus 3. All three of those pieces are going to multiply by what? X minus 5, x minus 3. I'm going to multiply the middle piece by x minus 5, x minus 3. And I'm going to multiply my end piece by x minus 5, x minus 3. I know that's overkill for some of you, but some of you are loving it. So we're going to meet in the middle. Well, no, not really. I'm just going to do it. Okay. X minus 5, x minus 3. How do we make that a fraction? Put over 1. Okay. So let's go through and do some canceling. X minus 5, x minus 3 times 1 over x minus 5. What cancels? X minus 5 cancels with x minus 5, and I'm left with x minus 3 times 1 technically, but it's really just x minus 3. Plus, second fraction. What cancels? X minus 3 cancels with x minus 3. What remains? The x and the x minus 5 equals. On the right, what cancels? X minus 5, x minus 3, what remains? 2. Okay. There's a reason we did all that work, right? This is, I hope in your mind, a much doable equation. Hopefully it doesn't scare you near as much. So, let's start doing some math. We need to, what? Deal with that x minus 5 and just distribute. So I'm going to have x minus 3 plus x squared minus 5x equals 2. What do we get when we clean up that left side? I'm going to move my x squared term out front. And I have x minus 5x, which is minus 4x. Then I have a minus 3 and an equals 2. Thoughts on what to do next? What? Pause that thought. I don't want to factor quite yet. All right? Yeah. And subtracting the 2 is going to do what for us? It's going to make my equation equal to 0. And then I'll be ready to talk about Autumn's factor, yes? Okay, so make our equation equal to 0. I have x squared minus 4x, and now it's going to be what? Minus 5. And it equals 0. And now I'm ready to talk about factoring. Home stretch now. X squared minus 4x minus 5. It does factor, right? I'm going to be shocked if you get something that doesn't factor today. If you get something that doesn't factor in this homework, more likely than not, you probably made a mistake. It's probably supposed to factor. So, did you get this one factored? X and X, 5 and 1, and what were the signs? Minus 5 plus 1. Once you factor, what do? Set each part equal to 0. X minus 5 equals 0. X plus 1 equals 0. Running into my next problem. What do we get for answers? X equals 5. X equals negative 1. Okay. Now, your last step has to be to check for extraneous solutions. If you continue on right now, you're going to miss this problem. And you know Savas, they don't really do partial credit, do they? If you put in 5 comma negative 1, they're going to say, nope, you're wrong. Okay. I said it would be an easy check, right? The long way is take 5, plug it into the whole equation, see if it works. Take negative 1, plug it into the whole equation, see if it works. The shortcut is we're dealing with fractions. What do we know about fractions? What do we know about the denominators of fractions? Yeah. Well, what's true of a denominator? A denominator can never do what? Equal 0. A denominator cannot equal 0. If a denominator equals 0, that fraction doesn't exist. Do either of these answers make my denominators equal 0? Yeah, which one? 5? What happens right here if we put 5 in? 5 minus 5 is 0. Can the denominator be 0? No. So guess what? 5 isn't really truly an answer. Okay, it is what we call an extraneous solution. Yes, we legitimately got that answer, but when you plug it back into the original equation, it doesn't work. Okay, now does negative 1 work? Yeah, it should. The other answer that wouldn't work for sure would be a 3. But 5 is the one we got, so 5 is what we would call an extraneous solution. But negative 1 does work. 5 you wouldn't even enter in Savas. It's not a solution, okay? Unless Savas says, what was your extraneous solution, or did you have extraneous solution? That's the only place that's the only way you would enter it. Okay? So your solution is negative 1. And I guess we're stopping there. My plan for tomorrow will be to do at most 5 more examples, right? Because that's what I have there. And I would like to think I could get you some work time. We know what we're doing now, right? So I would like to think so. Honestly, you know a decent amount to probably go through and try some homework if you want to. I mean, I have some examples on here that will cover some special cases and whatnot, but you can start working on it if you want.